Now that we know a little bit about angles, our next goal is to start talking about the relationships that can exist between them. So we're just going to talk about several definitions here about the relationships that can exist between these two angles. We're going to start with the ones that have to do just with measures. So we have two types of pairs of angles here, complementary angles and supplementary angles. They have nothing to do with the placement of angles and have everything to do with their degree measures. So complementary angles are specifically two angles whose measures sum to be 90 degrees. And so I can have that in a couple different situations. I could, if I want, just have, an angle here and another one over here that if we were to add these up, these two angle measures, let's say this was 60 degrees and this was 30 degrees, their sum is 90 degrees. And so that is obviously one situation I can have, or I could actually have them share a vertex like this, a similar situation where if this is 30 degrees again and this is 60 degrees, I can say that these are complementary angles. So it has nothing to do about their location in space, it just has everything to do with their actual measures. Supplementary angles, on the other hand, are basically the same thing, where it's two angles whose measures sum to be 180 degrees this time. So the important thing for both of these is that it's not a set of angles, it is specifically two angles, and their measures just sum to be either 90 degrees or 180 degrees. So that's all there is to those. Let's see. So then the next set of definitions actually do pertain to the locations of the angles. So adjacent angles means two angles who share a common vertex and side. So what I mean by that is that if I have two angles here, and let's see, another one here, and I'll label these points so I can talk about them, A, B, and C, and D. I can say that angle A, D, B, and angle B, D, C are adjacent angles. And that's because they share a common vertex right here, which is D, and they share a common side, which is ray DB. So any two angles who share this side and this vertex, the vertex part being important as well, because if I have a situation like this, then these two angles share a side, but then that share a common vertex. So that's not what I'm talking about. I need two angles that specifically share a common side and a common vertex, and we call them adjacent angles. The next two are a little bit more interesting, and that is a linear pair and vertical angles. Linear pairs are two adjacent angles whose non-common sides are opposite rays. So we have to remind ourselves what opposite rays means. Opposite rays are two rays who share a vertex and then go in opposite directions. And so two adjacent angles whose non-common sides are opposite rays, that means they do have a common side, but these two non-common sides, they're opposite rays, that means they form a line. So they share a side here, but these two other sides are opposite rays from each other. So the two angles here in this situation would be angle CDB, and angle BDA, angle BDA. And so we'll notice some things about these. One thing that we'll notice is that these two angles also are going to make a straight angle, or in other words, they sum to be 180 degrees. So it'll be the case that a linear pair of angles will always be supplementary as well. And so I emphasize this because a common error that we're going to make here is thinking that supplementary angles can only be a linear pair, but any two angles that sum to be 180 degrees will be supplementary, specifically the ones that are adjacent to each other and then have non-adjacent sides that are, or non-shared sides that are opposite rays. That will be a linear pair. And then last but not least, we have vertical angles, and that's two angles whose sides form two pairs of opposite rays. So they share a vertex, and then they create two pairs of opposite rays. So when I say they create two pairs of opposite rays, that what I mean is that they form two lines. And so I actually have more than just one pair here, I have two pairs of opposite rays. So angle AED, angle AED, and angle BEC, would be a pair of vertical angles, and then the other pair, angle BEA and angle CED, would also be a pair of opposite rays. So, opposite angles, vertical angles, over two. So this would be a pair, and this would be a pair. And you might be able to come up with some interesting facts about those if you think about it for a little bit, but we're going to talk about that more later. All I really care about right now are these locations in space that they have. And so another common error that's going to occur here is making sure that we're matching up the correct angles, because when we start having situations where there's, multiple, it's a little bit off, multiple lines that all meet, it's going to be common for us to say things like these two angles, for example, are, a lot of times we'll say they're either a linear pair or vertical angles, and neither of them will be correct. This angle here will be a vertical angle to this one over here, and then it'll be a linear pair to this larger angle. So it's just something to be careful about that we'll get a little bit of practice with, but here's a set of 5 different definitions for pairs of angles. The first set had to do with their measures, and the second set just has to do with their location in space.